Rice is a cereal grain and staple food for many cultures worldwide, providing over 20% of the calories consumed globally, as it belongs to the major dietary grass family Poaceae with other grains like wheat and corn. In addition to carbohydrates and energy, rice offers a variety of health benefits through its supply of protective antioxidants, B vitamins, important minerals, digestive fiber, and compounds that regulate blood sugar, cholesterol levels, and heart health risk. Though it shares key compounds with related grains, rice is unique for its relatively low allergenicity, making it one of the most widely consumed food staples, providing key nutrition to population across the world. In the study of Kumar et al. 2018, therefore, the nutritional value and health benefits of rice as a globally important food source should not be underestimated.
Planting rice can be done in different ways. Example of methods when planting them are by transplanting the seedling, broadcasting, drilling the seeds in the holes or furrows. Choosing when to plant is crucial to establishing the crop in the field. Timely planting in the well-prepared seedbed will help produce a fast-growing, uniform crop that will have higher yields and better competition against weeds and pests.
Insect pests are creatures that can cause significant damage to rice fields, lowering yields and costing farmers money. In diverse agroclimatic zones, about 100 insect pest species attack rice crops during the vegetative and reproductive stages, according to Cluj 1997 and Sugao et al. 2003. Rice stem borer are one of the common insect pests encountered in rice farming. Stem borer bore into the rice stems, resulting in a decrease in grain quality, according to Pasalo et al. 2004. Leafhopper cause the plants to wilt, grow slowly, and spread viruses. The larvae of these tiny flies feed on the rice tissue, resulting in formation of galls and reduced growth of plant impacted. Weevils that cause damage and contamination to stored rice grains, resulting in a decline in quality and financial losses, are known as rice weevils. Crop rotation and maintaining healthy ecosystem and chemical control using insecticides when needed are frequently used in conjunction to control insect pests in rice.
So rice is a big deal worldwide, feeding over 60% of people globally. And in the Philippines, basically, it is our staple food known as palay, bigas, and kanin. It is a vital source of sustenance for millions. Farmers in the Philippines use traditional eco-friendly rice growing methods, but modern pressures for quick cash may disrupt these practices. Challenges include limited irrigated land, climate change impacting irrigation, urbanization reducing agricultural space, and rising costs affecting farmers' income. The solution? Conservation agriculture. Like zero tillage promotes a greener farming approach, striking a balance between tradition, feeding the population, and environmental consciousness.
There are four major insect pests in rice. First is stem borer, second leafhopper, and third is plant hopper, and the last is rice bugs. Rice stem borer destroy rice at any stage of the plant, from seedling to maturity. It causes significant yield loss due to their attack on rice, resulting whiteheads and dead hearts. The second one is leafhopper. Leafhopper is prevalent in lowland and irrigated wetland rice. It damages the plant by sucking sap, creating white patches, causing wilting, and potentially causing hopper burn. The third one is plant hopper. Plant hopper, nymphs and adults, sucks the plant sap from phloem cells, causing hopper burn symptoms and causing 1 to 90% rice yield losses. The last is rice bugs. Rice bugs cause significant damages during milking stage. It causes empty or deformed grain, depending on grain growth stages of it.
The white stem borer causes severe damage to Pakistani rice farm. Adult white stem borers resemble yellow stem borers in appearance. Every adult white stem borer's moth has identical appearance on the early phases of a crop. A white moth on a field exhibits an orange tuft on its anus. An adult female's range is 26 to 30 mm, where as an adult male's range is 18 to 24 mm by Hazar et al. 2023. According to Shin Talapati 2023, in order to evaluate the damage caused by the rice insect pest on treated and untreated rice plants, a field experiment was carried out in 8 different locations around India between 2018 and 2013. At different places, the prevalence of the following pest was noted: world maggot, thrips, brown plant hopper, white-back plant hopper, gall mage, leaf folder, and cased worm. Though not every region experiences a high prevalence of insect pests, the harm caused by this pest is greater in frequency and intensity when compared to treated fields.
Control measures of insect pests in rice. As part of integrated pest management, there are 6 control measures. First is the regulatory control. The second one is the cultural control method. The third one is the biological control method. The fourth one is the physical control method. And the fifth one is the mechanical control method. And lastly, chemical control method. Regulatory control methods in planting rice crops are typically applied when there is the need to manage pests, diseases, weeds that can significantly affect crop yield and quality. These methods involve the use of regulations, guidelines, and protocols to monitor and control the spread of pests, diseases, as well as to manage the use of pesticides and herbicides. For example, regulatory control methods may be implemented when there is an outbreak of specific pest or disease that threatens the rice crops in particular region. In such cases, government agencies or agricultural authorities may issue regulations or guidelines for farmers to follow in order to prevent the spread of pests or diseases and minimize the impact on the crop yield. The second method is cultural control methods in planting rice crops are typically applied to manage various aspects of crop growth, development, and environmental conditions. These methods focus on cultural practices and techniques that promotes a healthy and productive rice crop while minimizing the impact of pests, diseases, and weeds. Cultural control methods are often preventive measures integrated into overall crop management strategy. One common scenario for applying cultural control methods in planting rice crops is during the early stages of cultivation. Farmers may implement practices such as proper crop rotation, selection of disease-resistant varieties, and maintaining optimal planting densities to create a favorable environment for rice plants and reduce the likelihood of pests and disease infestations. According to Fahad et al. 2015, biological control methods is the use of natural enemies such as parasitoids, pathogens, and predators. The best time to apply biological control methods for controlling insect pests of rice crops is typically during the early stages of pest infestation or before planting. Biological control involves the use of natural enemies such as predators, parasites, pathogens, or any competitors to regulate pest populations and minimize the crop damage of insect pests. For example, introducing predatory insects that feed on pest species before planting or at the onset of plant infestation can help establish a balanced ecosystem in the rice fields and reduce the risk of pest outbreaks. Additionally, using biological control agents that are specific to target pests minimize the impact on beneficial insects and other non-target organisms.
Physical control measures. The physical methods are those which are used for pest control to reduce pest populations by using devices which affect them physically or alter their physical environment. Temperature, sound, controlled atmosphere, and radiations are employed as important methods of physical control. According to Bayegunhi 2019, adoption of physical control measures by rice farmers will affect rice quality and can result in higher sales profits through the market mechanism of higher quality with better price. thus increasing the income of rice farmers. In addition, physical control also refers to the mechanical or handheld controllers that target and eradicate pests. Weed control is primarily accomplished by physical measures. Weeds are killed and prevented from producing through tillage, fire, hand eradication, grazing, and mowing. Tillage can also kill some insects by destroying their eggs or overwintering stages for development. Weeds are not eliminated with a single operations. Mechanical control methods. Mechanical control methods is done without the use of chemical pesticides. These strategies control insect population by physical interventions. Insect pests are commonly managed in rice farming using the following popular mechanical control methods. First, the hand picking entails physically eliminating insect pests from the rice plants by hand. Second, the mechanical traps. Insect pests are intended to be captured and eliminated using the mechanical traps. Third, physical barriers. By erecting a physical barrier between the crops and the pests, these barriers lessen crop damage and infestation. Fourth, flooding. To prevent the detrimental effects on the ecology, this strategy needs to be carefully managed and might not be appropriate for all the insect pests stated by the general approaches to insect control. And the last, the light traps. These are the gadgets that use light sources to draw insects in and then use sticky surfaces or other mechanisms to trap them.
Conclusion. Rice cultivation faces challenges from various insect pests that can cause significant damage and reduced yields, leading to financial losses for farmers. These pests include rice stem borers, yellow stem borers, striped stem borers, rice leaf holders, brown plant hoppers, green leaf hoppers, and rice weevils, which attacks the rice crops during different stages of growth. To manage this pest, farmers employ a combination of regulatory, biological, cultural, mechanical, and chemical control methods. This approach aims to reduce pesticide use and promote environmentally friendly pest control practices. Practices such as proper field preparation using certified seeds, maintaining optimal planting density, and timely planting can improve yield. Integrated pest management (IPM) techniques, which combine biological, cultural, physical, and chemical tools, are recommended to minimize economic, health, and environmental risk. Biopesticides derived from natural materials are preferred over chemical pesticides.
Proper irrigation and the use of organic fertilizers are essential for nurturing rice as it's a water-intensive crop. Studies have shown that using certified seeds and implementing IPM practices can increase yield and reduce pesticide use significantly.
Overall, rice is a vital grain and a staple food in many cultures worldwide. By implementing sustainable and integrated pest management approaches, farmers can effectively manage insect pests, minimize environmental impact, reduce reliance on chemical pesticides, and ensure the long-term productivity and sustainability of rice production. These efforts can contribute to protecting the environment, supporting food security, and maintaining a stable food supply for the population.